Why should you study mathematics? This guide is for students, parents and carers at Untitled Chapter. Mathematics is a well-respected subject by employers and higher education, and as such it can lead you to study lots of different qualifications. Studying mathematics helps develop key employability skills. For example, problem solving, communication, logical reasoning, and resilience. Studying maths in sixth form will increase your knowledge and understanding of various mathematical techniques and their applications. It will also support the study of other A-levels you may be studying. It's excellent preparation for a wide range of university courses. And finally, it's stimulating and challenging. From a global perspective, we are a tiny island that is part of a global economy. The UK is one of a few countries in the world where the study of maths is not compulsory after the age of 16. Students will be competing for jobs with people who've studied maths at least up to the age of 18, especially if they're considering studying or working abroad. Creative and technological advances will make maths more important than ever. This is why jobs that require maths skills tend to pay more. Therefore, if you achieve a good pass at GCSE in mathematics, then you shouldn't be asking, shall I take maths in sixth form? But instead you should be asking the question, which maths course shall I take? At Treferris, we offer mathematics, further mathematics, core maths, and finance. Both mathematics and further mathematics can be taken as an AS at the end of Year 12, which covers roughly the first half of the content of the full A-level. A requirement to study further maths is that you're also studying maths, as it builds on the topics you study in maths. Taking maths and further maths could therefore mean spending either half or 2/3 of your timetable just on maths. Level 3 core maths is of the same size as an AS level and is therefore ideal for students wanting to continue with some maths in addition to their level 3 programme. At Treferris, students complete the core maths during Year 12 and then have the option to study a level 3 certificate in finance in Year 13. The finance certificate is equivalent to an AS level and graded A star to E. Both core maths and finance attract the same UCAS points as other AS levels. In our current Year 13 cohort, some students who study core maths as a fourth subject in Year 12 have decided to focus on their 3 other subjects in Year 13 and not study the finance qualification. Other students who are studying core maths as one of their 3 subjects have chosen to complete the finance qualification in Year 13. In 2017, the Department of Education changed the process of awarding AS and A-level qualifications and decoupled the AS qualification from the A-level qualification. This means that the marks from an AS qualification no longer count towards the A-level qualification. The AS level is a great qualification in its own right and covers roughly the first half of the A-level maths course. At Treferris, students can choose whether to sit AS level maths at the end of Year 12 or to take A-level maths at the end of Year 13. The content studied is the same across all of the exam boards for maths. At Treferris, we follow the OCR MEI specification. All of our students are loaned textbooks to support their independent study. In both Year 12 and 13, you will study three main strands of maths: pure, statistics, and mechanics. 2/3 of each year is pure content, with both statistics and mechanics making up 1/6 of the content. AS or A-level maths is for any student with at least a GCSE Mathematics grade 6. You have already studied a lot of pure mathematics in both primary and secondary school. All of the number, algebra, and geometry topics you have come across fall under the branch of mathematics that we refer to as being pure mathematics. For example, you'll look at problems like this. The points A and B have coordinates 4, -2 and 10, 6 respectively. Find the equation of the circle that has AB as a diameter. You have also studied many aspects of statistics, which include probability, averages, and statistical diagrams such as pie charts, cumulative frequency diagrams, and histograms. During your study of statistics, you will analyse data to draw conclusions about the likelihood of an event occurring. An example of the types of questions you will study is: what is the probability of 2 100-year floods happening within the space of 5 years? What assumptions have you made? In mechanics, you'll look at how we can apply pure topics of mathematics to model the world around us. It is such an important aspect of describing the world around us that if you're studying A-level physics, you will also cover a lot of this work as part of your study. If you're planning a career in physics or engineering, then you will find this topic very useful. For example, a golfer drives their ball from a tee on the horizontal ground so that it has an initial velocity of 50 meters per second at an angle of 40 degrees above the horizontal. How far down the fairway will the ball land? In the UK, A-level entries for both maths and further maths have steadily increased over the last 15 years. In 2020, mathematics was again the most popular A-level subject, and further maths was the 16th most popular, with more entries than PE, law, computing, or languages. Lots of subjects make use of maths, so if students are planning to study any of these, they should think about taking a maths qualification alongside. The larger the oval, the more maths is in the subject, and so further maths should be considered. Subjects with smaller ovals would be well supported by either A-level maths or level 3 core maths. The blank ovals indicate the fact that there are many other subjects that have maths in them, such as product design, music, graphics, etc. I should stress that the skill development that comes from studying A-level mathematics means that students would benefit from studying the course in conjunction with many other subjects. Maths can support biology, chemistry, business studies, economics, computing, geography, physics, and psychology in particular. On this slide, you can see the percentage of maths content in each subject. National data shows that of all students taking at least one A-level, boys are almost twice as likely to choose A-level mathematics and almost 3 times more likely to choose A-level further maths than girls. There's been a lot of research into why boys are more likely to continue studying maths at A-level, and one of the findings was that girls were less likely to opt for maths if they perceive it as being a boys' subject. Therefore, we felt it is important to stress that the number of girls taking the subject is high, with it being the 4th most popular A-level subject for girls to study. This slide lists some of the possible misconceptions about who might take core maths, A-level maths, or further maths. Maths is in fact a subject that is relevant to many careers and is not solely associated with physics and engineering careers, and we have already seen that maths is the 4th most popular A-level for girls. Mathematics and further mathematics are versatile qualifications, well respected by employers and for entry to higher education. Careers for men and women with good math skills and qualifications are not only well paid, but they are interesting and rewarding. People who have studied maths are in the fortunate position of having an excellent choice of career, as illustrated by the wide range of career titles shown here. This quote is taken from the review of Post-16 mathematics to demonstrate how vital math skills are not only in STEM occupations. Quantitative skills are required in a wide range of occupations and activities, embracing not only the mathematical and physical sciences, but also the social sciences, the humanities, and the creative arts. Mathematics is now intrinsic to some aspects of the creative arts, and learned societies argue that students across the sciences, social sciences, and humanities need significant quantitative skills, and these should be a central component of their education. Studying mathematics has the potential to lead to careers which are financially very well rewarded. Research by the University of Nottingham has shown that students who have studied A-level maths on average earn 11% more by the age of 34. The average salary 6 years after studying further maths and maths A-levels is £25,500. On this slide you can see how this compares with other subjects. There are a large number of careers in which maths is essential or beneficial. For example, epidemiology, modelling diseases, and controlling infections. Taking maths at A-level is more helpful for landing a place at a Russell Group university than studying at a grammar or private school. Research from the University College London's Institute of Education suggests. There is even a maths premium for degree subjects that are not directly related to maths or which require a different skill set, such as languages and humanities. This slide shows a differentiated offer which emphasises the way that further mathematics is considered important in preparation for a mathematics degree. Taking AS or A-level further mathematics reduces the offer. The second example shows that a failure to take A-level further mathematics can limit access to the most prestigious STEM courses. This slide shows that further mathematics is often indicated as a preferential qualification for engineering in addition to required subjects. For many engineering degrees, courses starting in 2021, A-level maths is now the only compulsory subject. Here we can see an example of a differentiated offer which shows the importance of maths, as well as other sciences, as the optimal subject combination for entry to a chemistry degree. It also shows that mathematics underpins many scientific pathways. At GCSE level, many students may identify geography as being the most relevant course to studying subjects such as earth science and meteorology, without realising how mathematical these topics become at undergraduate level. Here we can see that the generality of A-level mathematics is often preferred to specific subjects more closely related to the degree course being offered. Students may be surprised to see that A-levels in psychology and economics are not necessarily essential for taking the subject onto degree level, underlining the flexibility and currency of A-level mathematics. In addition to investigating formal entry requirements, students should also be encouraged to consider the profile of undergraduates on courses. Competition for places on some degree courses is high, and students should consider taking A-level mathematics and further mathematics in order to distinguish their application, secure a place, and help them succeed once they start the course. In some cases, a qualification in core maths or A-level maths/further mathematics will reduce the grades required for entry to a degree course in a related subject.